VTC consists of the VTC oil control valve installed in the cylinder head and a hydraulically controlled VTC actuator mounted on the end of the intake camshaft. The VTC actuator includes a body, a vane-type rotor that indexes to the camshaft, chamber seals, a lock pin assembly, and front and rear covers. A special VTC camshaft with extra oil passages directs oil pressure to the actuator. When the body and rotor are mated together, they create advanced chambers and retard chambers on either side of the rotor vanes. The movement of the rotor is hydraulically controlled by oil pumped through the oil control valve. The difference in oil pressure between the advance and retard chambers turns the rotor and rotates the camshaft in either the advance or retard direction. Under certain conditions, the lock pin mechanically locks the rotor to the body in the fully retarded position. The oil control valve, or OCV, consists of a 12-volt solenoid that drives a spool valve within an aluminum body. The oil control valve has a single oil inlet, but two outlets, one to the advance side of the actuator and one to the retard side. The valve also has two built-in oil drain passages. Oil from the oil pump travels through a passage in the block to a junction. From this point, oil is supplied to both the VTEC and VTC systems. Oil flowing to the VTC system passes through a serviceable filter screen and into the oil control valve. Depending upon the position of the spool valve, oil flows to either the advance side of the actuator or to the retard side. The valve only has two positions. When power is applied to the solenoid, all oil flowing through the OCV is directed to the actuator's advance chambers. When power is not applied, a spring pushes the spool valve to the retard position, and all oil flow is directed to the actuator's retard chambers. As one end of the spool valve opens a passage from the oil supply to the actuator, the other end of the spool valve opens a drain passage from the actuator to the sump. Oil flowing to and from the actuator travels through two passages drilled in the cylinder head, through the number 1 cam holder, and into the intake camshaft. Whether VTC is operating or not, oil is always flowing through the oil control valve to the actuator. Continuous oil flow through the system is critical because the oil supplied to the VTC actuator also provides the sole source of lubrication for the number 1 intake cam journal. The intake camshaft is hollow as on other engines, and oil supplied to the number 3 cam journal also lubricates number 2, number 4, and number 5 journals through the camshaft. But since the oil that controls the VTC actuator is routed through the number 1 journal, the two systems require separate camshaft passages.